Good morning. This presentation will introduce the components of the MEDINA framework used to implement the customization of requirements functionality. The customization of requirements involves three components, which are the NL2CNL Translator, the CNL Editor, and the DSL Mapper. This functionality allows the user to select a requirement, associate it with a set of security metrics, customize it, and then send this information to the assessment tools. Each component will be described in 3 chapters. First, an overview of the component will be provided, then the use of the component will be explained. Following, a short part on the installation steps will be shown. At the end of the presentation, some additional information will be provided. The first component is called NL2CNL Translator. This component aims at associating a requirement with a set of security metrics that can be suitable to represent that requirement. Both requirements and metrics are expressed in natural language, so this component will also translate them into an intermediate language called Controlled Natural Language, or CNL. Finally, the translated requirement and the associated metrics are saved into an object called REO, which is stored in a database provided by the CNL Editor. The NL2CNL Translator is not provided with a user interface, but it offers a RESTful API to be used by the other components of the MEDINA framework. The NL2CNL Translator uses the catalog of controls and metrics as the source of information to retrieve the security requirements to be assessed, and the set of metrics that can be associated with requirements. For the translation, the component relies on natural language processing techniques, and therefore requirements and metrics are represented by NLP features, which are pre-computed and preloaded. The output of the NL2CNL Translator is an XML object containing all the information, which is stored in the CNL store of the CNL Editor. This is a diagram of the MEDINA framework architecture, where you can see the NL2CNL Translator, and how the information is flowing to and from the other components. Specifically, the process of translation is triggered by the orchestrator, through its user interface. The orchestrator sends to the component the ID of a requirement to be translated. Then, the NL2CNL Translator connects to the catalog of control and metrics, to retrieve the requirement, and to select the metrics that better describe it. Finally, the NL2CNL Translator encodes all the information into a REO object, and sends it to the CNL Editor. Let's now take a closer look at how the NL2CNL Translator works. The first operation performed by this component is the association of a set of metrics to a requirement. To this aim, the NL2CNL Translator relies on an internal module, which is called Metric Recommender. Given a requirement, the Metric Recommender transforms it into a numerical representation by using NLP features. The same is done for all the metrics available in the catalog. Then, the Metric Recommender computes the similarities between a requirement and metrics. The most similar metrics are associated with the requirement. The whole process is automatic and transparent to the user. At this point, a requirement is associated with a set of metrics. Then, the NL2CNL Translator translates metrics into obligations, which are policies expressed in a controlled natural language. Finally, all this information is wrapped into an object called REO, and saved in a database of the CNL Editor. This process is also automatic and transparent to the user. Let's now look at some technical details about this component. The NL2CNL Translator is developed by using the Fast API Web Framework in Python 3.8, and it is containerized in Docker. To install it locally, it is possible to clone the code, which is stored in the GitLab repository of the project. Then, the build command and the docker run command can be executed. As mentioned before, this component does not have a graphical interface, but can be tested via a web API. The web API can be accessed at the local host. Regarding technical specifications, the NL2CNL Translator requires Python 3.8 and Docker Compose for the installation.
Let's now look at the second component, which is the CNL Editor. We will see its purpose and its role in MEDINA architecture. The CNL Editor is the component that allows to a user with a web interface to make customization of real objects. A real object is an association between a requirement or security control and obligations. Obligation is a statement written in CNL language that expresses a compliance policy in this form: metric name, must, resource type, operator, target value. This means that to a specific resource type must be applied a matrix with specific operator and target value to be compliant. The user can visualize all RIO for the cloud service ID that are in the user profile in Keycloak. So user can see only the RIO relative to cloud service ID but the user is authorized. For this RIO, user can make some changes like deleting some obligations or modifying the target value specified in the obligation. The components has also some API that can be used from the other MEDINA components to create, research, and retrieve the RIO objects. The component uses an ontology that is stored in a static file, the vocabulary. The ontology is derived from the catalog of controls and metrics, whose details you can see in another video of this series. And the ontology, there are the metric name that for the editor are actions, and other terms like resource type, target value type, and operator. The tool has some tooltips in the web page to have information about the field contents and also a button to invoke the user manual that is a PDF file. This is the diagram of the MEDINA architecture. You can see in the upper left side of this diagram the CNL editor and these interactions with the other components. The NL2CNL Translator creates the real objects that are stored from the CNL editor in a specific database. The editor can visualize and manage this RIO, and at the end of the activity, the user can invoke the DSL Mapper that translates the policy from CNL language to RIGO code. In this slide, we list all the interaction between the CNL editor and the other components of the MEDINA project. One interaction is with the NL2CNL Translator that is an input for the editor. The translator creates the RIOs as XML files, and this RIO can be customized by CNL Editor. The other interaction is the output of the editor is with the DSL Mapper. The mapper is invoked by CNL Editor and it translates the obligations specified in the RIO into RIGO policies. The measure interaction is with the user that with the editor can consult the RIOs pertaining to Cloud Service ID that are in the user profile in Keycloak. The Cloud Service ID whose the user is authorized. And with the editor, the user can perform the customization of the RIOs. Now we will see a demo showing the functionalities of the CNL editor. In the demo, we will see the user that makes login to the CNL editor from the MEDINA UI. When the user makes login, we'll see a list of RIO filter based the Cloud Service ID. Each RIO has stored in it a Cloud Service ID, and in the user Keycloak profile, there is a list of class service ID whose user is authorized. So the list of RIO that user can see is filtered based on the class service ID. The user can select a REO and on it can make one of these operations. Show RIO details to see the control and the policy specified in the REO, or edit the REO to change the operator, the target value, or delete obligations. To map the REO, that means invoking the DSL Mapper, or delete the REO. This is a demo of the CNL Editor, one of the components of the MEDINA project. You are seeing now the web page of the integrated MEDINA UI, where the user can make login. User insert username and password, and in this way access to the MEDINA integrated UI. On the left side you can see the menu where are all the tools of the project. To invoke the CNL editor, the user can select customization of requirements. The CNL editor shows to the user a list of REO. REO is an association between a requirement or security control and all its obligation. The obligation is a policy where a metric must be applied to a resource to be complied. From this page, the user can see his profile, where are defined also the cloud service ID, but the user is authorized, in this case, to cloud service ID. And also, from this web page, the user can select the help button to read the manual of the CNL editor. The CNL editor presents all the REO of the user that are defined for the cloud service ID that are in the user profile that we saw before. If the user selects one REO, he makes some operation that are specified in the right part of the web page. The show presents all the detail of the specific REO. This page is divided into parts. The upper part, where there are the metadata of the REO, and the second part, where there are the obligations. In the first part, you can find the status of the REO, in this case customized, so it's customizable, the cloud service ID of the REO, the unified identifier, the vocabulary that is used to define the REO, the requirement code, the security control, the source framework, UCS, the type of metrics, organizational or technical, and the assurance level that can be base, substantial, or high. In the bottom part, we have the policy, in this case 5 policies, that are statements with this form. Resource name, must metric name, the metric that must be applied, an operator, and a target value. In this case, target value is type Boolean and the value is true. On the right side, you can see if the metric comes from the catalog of controls and metrics or it comes from the recommender. And here are the tooltips that give some information about the metrics. If we come back to the list of REO, we can choose another operation. If we choose the edit, we can make some changes to the REO. For example, we can delete an obligation, selecting the red button, or we can change a value for the target. Then the user can select to update to store the RIO with these changes. Can select back to come back to the list of RIO without confirm these changes, so the RIO remain unchanged. Or the user can complete the RIO, so confirming all the changes. As you can see, the status is changed from customized to completed. Now, the user can select another operation, that is the map operation. Map invokes the DSL Mapper, another component of the project, that translate the policies that are written in CNL language, translate in Rigo codes. So, if we select map, map is completed with success, and the RIO pass from the status completed to the status available. As you can see here, the demo is finished. I thank you for your attention. Now I'll give you some information about the deploy of the CNL Editor and about the software. The CNL Editor is developed using the microservice architecture. It is composed by 5 microservices that are implemented as Docker container. The software is stored in the GitLab private repository of the project that is here specified, and for the build we use this statement. About the software, we can say that it is developed with Java and the use of Spring Boot for the API and the application logic. For the user interface, we use the Google Web Toolkit and Vaadin, and the operations of RIO, like create, read, update, and delete, are available through REST API. We use Docker Compose for installation.
The last component is the DSL Mapper. This component reads a RIO object from the database of the CNL Editor to retrieve the corresponding obligations. Then, it translates the obligations into policies expressed in a domain-specific language, or DSL. In the context of MEDINA, the chosen DSL is the Rigo language. The Rigo policies are then sent to the orchestrator to be assessed. The DSL Mapper is not provided with a user interface, but it offers a RESTful API to be used by the other components of the MEDINA framework. The DSL Mapper uses the database of the CNL Editor as the source of information to retrieve the RIO object and its corresponding obligations. The output of the DSL Mapper is represented by 2 files for each obligation, written in Rigo language. They contain the implementation and the configuration corresponding to an obligation. These files are sent to the orchestrator. This is a diagram of the MEDINA framework architecture, which shows the DSL Mapper and its connections with the other components of the framework. The DSL Mapper interacts with the CNL Editor, which triggers the mapping process through its user interface. Moreover, the DSL Mapper accesses the database of the CNL Editor to retrieve the RIO to be mapped. Finally, the DSL Mapper interacts also with the orchestrator to send the obligations mapped into Rigo policies. Let's now take a closer look at how the DSL Mapper works. The DSL Mapper is triggered by the CNL Editor through its user interface. When a user hits the Map button in the CNL Editor UI, the DSL Mapper is invoked, with the ID of the RIO to be mapped. Then, the DSL Mapper reads the specified RIO from the database of the CNL Editor, and retrieves all the associated obligations. Each obligation is translated into a Rigo policy, which is finally sent to the orchestrator. The orchestrator will assess obligations according to the operator and target values specified in them. The whole process is automatic and transparent to the user. Let's now look at some technical details about this component. The DSL Mapper is developed by using the Fast API Web Framework in Python 3.8, and it is containerized in Docker. To install it locally, it is possible to clone the code, which is stored in the GitLab repository of the project. Then, the build command and the docker run command can be executed. As mentioned before, this component does not have a graphical interface, but can be tested via a web API. The web API can be accessed at the local host. Regarding technical specifications, the DSL Mapper requires Python 3.8 and Docker Compose for the installation. We have almost reached the end of this presentation. To finish, I will show you some links to useful resources about the MEDINA project. If you need more details about the components presented so far, or about the MEDINA project in general, you can visit the official webpage at the first link. There you will also find all the public deliverables of the project. Project-related videos are also available at the second link, such as demos and training videos. The third link points to the MEDINA community in Zenodo, where among the other things, the articles published during the project are available. Finally, the source code of the project is available at the last link. And that's all. Thank you and goodbye.